streaming takes a lot of bandwidth, and it probably wouldn't work very well. Like it would probably glitch out and like slow down or whatever. All right, so yesterday we started this lesson, right? Because we got through the other lesson so quickly. We talked about the Rio Grande. I got nice and off topic and talked about trains killing people by launching rocks out of their wheels. And shout out to Mr. Stockdale because he's awesome. Yeah, he's going to watch this video. Tom Stockdale, who's probably at this point, well, when I was in high school, I think he was like
30-something?
No, like 60 or 70. He had retired. This is how cool he was. And I'm still trying to figure out if we have everyone here or not. He had fought in the war, because like the age he was, most of those people went and fought in the war. So he had a military pension, which is like your military kind of like retirement. You continue to get paid from your military service. He then became a teacher. He's like a scientist, so he knew physics, everything else. Retired from teaching. The school could not find anyone to take his place because he taught like advanced courses, honors courses. So this guy, in his first teaching career, taught my father, right? The school rehires him because they can't find somebody to fill his spot. So he now has his retirement, his pension from the military, his retirement from his first time teaching, and now he's getting paid to teach again.
Wow.
He teaches another round of a few years. My brother goes through the high school. He retires again, saying like, I'm tired. No, I have an older brother and an older sister. Yeah. So then I think he's retired for like a year or two, and the school's like, we can't like do these honor classes. They rehire him again, wow. But he says, I don't want a homeroom, I don't want any study halls, and I only want to work during the morning. So he essentially told the school, here's what I want. I want to teach only honors classes, I want the top students in the school, and I don't want any of the nonsense.
They keep making him
so then not making him, they just keep offering him, and I'm sure they paid him like a decent amount at that point. So then, in his last time of teaching, I then came through. So he ended up teaching my father, my brother, my sister, and me. So it's kind of a weird span. But that's how awesome of a teacher he was. He's pretty old. When he was our teacher, he was still like going out bow hunting, like for deer. So like you hunt with a gun, like whatever. Yeah, you can shoot something, but bow hunting is legitimate. So we were going to do this, but I think I'm going to have us do that like as a mastery or some other activity. The whole like write a description of how to get somebody to get your dilated shape. Because remember we're talking about we talked here about which one of these make like a valid, like we can only have one option of the outcome. So really I just kind of want to talk about this problem really quick, make sure we're all solid on these two applications, especially 101. And then we'll hand back to chapter 9 tests and go over any questions. I think we're just going to do corrections on that, but I might make another supplemental activity for us to go over next week, depending on how you guys do with the corrections. Like, if it's still really iffy and we need to review stuff, remember, so I like to refocus us on this, none of this is, like, punitive, like punishment sort of stuff. We just all have the same goal, right? We want to all know this stuff to the point that we're, like, really comfortable and we've got it mastered. So, if we're not there, we should put more time into that learning process. Yeah?
Yeah.
Makes sense, right? We don't want to move on with stuff until we really have it. So when I look at these two shapes, can we determine, based off the sides that we have, that they're similar? And if so, what's your scale factor? So realize he took figure A, if we read this, enlarged it to become figure B, and it tells us that they're similar, so it kind of gives that away. You want to determine the scale factor and then figure out X. If you get that done, I will warn you, 101 is different. Try 101. I'm going to give you a few minutes to work on this. I may just pass back your test right now because that makes sense. You're doing 100 first and then 101. We'll go over these tests in a minute. Please just hang on to these. Leave them out. You don't need to look through it right now. We'll take some time on these in a few minutes. Sorry. My brain. I look at like 3 at the same time and then I drop things in the wrong place. Sorry.
4 plus 2 is 6.
Ooh, be careful. I hear you talking about adding things.
Oh, be careful. We're going to try that. And then the other way to do it is
Places, going on school visits, making my job. You have 101 done? You look like you're bored. Exemplary. No, don't really tell your mom about that. That's like put on your fridge.
Whoa.
You get an exemplary, you should be proud of that. No. So I like to get you guys your things back before I put them in math, and the report goes home today. I'm not going to put these in before the report goes home because I want to give you an opportunity to fix it before I put grades in. So if you fix it tonight and get it back to me by tomorrow, I will put in the updated grade over the weekend. If you don't, it's okay. It's just gonna go. Yes, I'm handing out everyone's. Don't worry.
Oh, so this won't be posted until the weekend?
Yeah, there's homeworks in here also. Yeah. Sorry. I keep doing this to people. All right. I need to not answer questions right now. I just need you guys doing 100 and 101 because I can't keep my focus. Start talking with people. Valerie. Let's just practice. Check. You might have gotten stuck with some of these. Let me verify that I actually have that document. Your homework. Here's your homework, and that has a check. I don't know why. Are we okay?
No. It's been going on for days.
Sorry, but the thing got buried. I saw it and then shuffled through things. So is Lizzie on the school visit probably? And Mari probably on the school visit. That's lame. No, it's being sick is lame. I like end up sleeping and doing nothing, and that's like the lamest thing there is. Who can talk me through 100? I feel like somebody else could come up here and be the teacher. You don't need me. Rock, paper, scissors, decide who's, or team up and do it. The other one of you could do 101.
Yeah, I'll do 101.
All right. Mr. Vantel needs your attention. Give him more respect even than you give me. I mean, okay. Mr. Vantaliano at your service.
So for A, it should have been you just can break down the ratios, which would be 4 to 10, 2 to 5, then 7 to X, which is when?
2.5?
Yep.
But teacher, 4 to 5 doesn't, or 4 to 10 doesn't make 2.5. 4 to 10 makes 0.4.
No, but like the
Cough, cough, other way around, cough.
made a mistake. I'm sorry.
When we're enlarging, and he didn't do anything wrong really, but make sure that when we're enlarging, your bigger number comes first, divided by your small number.
I made a mistake.
All right, continue, Mr. Vantaliano.
So then for B, so beta A would be
So what'd you find for X?
I found for X 2.5.
That's what X is. X, the side
no,
X.
No, 17.5. I'm sorry.
There we go.
Okay, I'm bad at this. And then for C, find two different ways to do that. I did this 4 times 2.5 equals 10, and 2 times 2.5 equals 5 to make that. But it probably should be bigger to smaller.
So the other way they're wanting you to compare it
is yeah.
Anyone has a way that doesn't just like use the scale factor?
Well,
He's
you
in
should have
charge.
just done this in general.
What?
You should have just done this in general.
Okay, so if you have 4 and 2, that makes 6, you get 15 when you scale it up. And so if 1 is 2.5, you just add the 2.5 onto the 15, which you got from the 4 and the 2. You get 17.5.
It might work, but that's a dangerous route. If we compare a shape, a part of a shape with itself, like what about the 7 compared to the 4? 7/4, right? Like 1.75, right? 7/4, wouldn't that come out to be 1.75? Yeah, somebody verify, please, maybe. We shouldn't need a calculator, right? We compare 7 to 4. Thank you very much, Mr. Vantaliano. 7 compared to 4 with the bigger side compared to the shorter side, 1.75. So if I go to compare that over here, 17.5, because this side is 1.75 times. If they're similar shapes, they have to keep that relationship. So whether I go from little shape to big shape, or little side to big side, and then little side to big side, either way would get me there, because those relationships have to hold true. All right, are you going to be Mr. Wilson, or are you going to make something else up?
Mr. Wilson.
Mr. Wilciano?
No, it's Mr. Wilson. It's Mr. Wilson. Alright, so class, today we'll be looking at that one. Alright, 6-101. Now, Fatima does this problem, but she got 30 for P. And she knows she made a mistake, but she just doesn't know what it is. She knows she made it. What would make her think that she got her answer wrong?
Less than bigger than how confused it was.
Yes. So if you look, she got 30 as P, but this is enlarging into this. So how could P be less than 45? Because it's flipped. It's the same shape, just different ways. It's rotating. That's all.
What's the right answer?
I didn't figure that out since it didn't tell me. Never told me.
Wait, Connor, why are you saying 1.5?
I tried it because 50 plus 1.5 equals 75.
So that's your, what? What do we call that? That 1.5 is scale factor. And then you're like right there. So Quinn said this 100% accurately. This side matches this side, but why Fatima got goofed was this side goes to the bottom, and then my short side. So Connor said if we compare here to here, 1.5. 75 is 1.5, 50. So I need to do 1.5 of 45. So 45 plus 22.5. 1.5, right? So 67.5. Are there any questions? Thanks, you. Are there any questions about how to use the corresponding sides in similar figures? So now, look at your mastery, and let's start taking questions on that. Essentially, the rest of this class time is for you to work on revising that mastery, and if you can't revise it on your own or with the help of a friend, and that doesn't mean let me see what you did. It means, hey, can you help explain this to me? Can you, like, tell me what you did? Not just, like, let me write down what you wrote down. Because by the like, I put attention on everybody's test. When things seem oddly familiar, they seem oddly familiar. Right? So don't just copy somebody else's answer. Make sure it makes sense. So I'm going to take a moment to pull up the test, look through your test, see if there's any questions. You're like, I really thought I had that right. Like, what the heck? And don't just immediately ask, though. Think about it for a minute. Try to reanalyze that problem. Even if you got a mastery, if you missed a couple, like, I'd love to go over what you missed. Yeah?
Question.
Like, can I get the test up first? Like, we're going to do it all together. So take a minute on your own to look over your stuff. What's up? Camera takes a minute to load up. So we're going to go through and I'm going to first show you the right answers. I want you to take a moment to figure out if you can determine how to get there. And then your revision, if you have a progressing, you need to get out a separate sheet of paper. Like, come on, we know that, guys. Your revision needs to show the work or have a written description of why you had it wrong. Like, oh, I missed the fact that this says it's coiled 3 times. Or, you know, whatever. So in, try to get this lined up so it looks right. In 1, I think the thing that caught people mostly on D was this asked for the radius, this asked for the diameter. We change up what we're asking about. So 1, circumference, most of us got this, most of us got this. C and D were where people tripped up a tiny bit. 2, you did not have to be exact. Really, a lot of you just said, like, yeah, his estimate is you know, fairly close. If we're being exact with 6 feet, that's what it comes out to be, but anything close to that, I accepted. Anyone want to go over 1 or 2? Yeah. Yeah, so, and this is like real world thinking in a way of like, I don't want to actually stretch out my entire garden hose to figure out how long it is, but it says a garden hose is coiled 3 circles, right? So like 1 big, 2 big, 3 big, and approximately I judge it's 6 feet across, and I'm 6 feet, 6 feet 2 inches, but I normally like think in my head, can I lay myself there? Okay, that's 6 feet. It's like that table, probably a little less than 6 feet, because I can imagine myself laying, and my feet would probably stick off from my head, right? So like that's how people approximate lengths. So it says if it's 6 feet across, 1 coil, well, what's the circumference approximately? Don't give me the exact, approximate compared to the diameter.
Approximate is the answer.
Did you listen to the question I asked? Okay. What is the approximate relationship between circumference and diameter? The exact is pi, but approximately it's 3, right? What's triple 6? 18. So he assumes every circle is 18. So 18, 18, 18, but 18 is kind of gross to work with. So if I say 20, well, that would get me my 60, right? 3 loops of 20. But I know it's less than 20, so that's why he says, between 50, 60. We're right around there. I have been in a situation, you guys have to think I make this stuff up. I've been in a situation where the hose wasn't long enough, and then we had to use the mathematical thinking to get the water to the tree, because I used to landscape. So we were all the way at the end of the hose, and the tree is still, like, over there. How could we still get the water to the hose, or to the tree? Just, like, so my thumb, I put my thumb on the end, and it still doesn't quite reach. This is real mathematical thinking.
Down by a bit.
Arc. Oh, yeah. If you arc your spray, make a parabola, is what that's called, and you'll learn about that in 2 years. If you make a parabola, that's how you can maximize the distance, because you will shoot all of the effort going up, and then you get to ride gravity down. So it's how you better utilize. Yeah.
So what's that shape? How to hold?
Yeah, it's just.
By drawing that, I can't really get that.
It's so if you read this, it's coiled into 3 circles. You didn't really need this shape.
I just can't imagine be there.
So ignore that. Like it's just I gave you all the info. It's an estimate. All you're trying to say and explain is his estimate reasonable? And if you made a good argument for why it wasn't, I'd probably accept it. But this is a big range. It's a pretty reasonable estimate. Because the exact is 56, right, 0.5. Even with these little extra pieces, yeah, it'd still be probably 60. Like under that or something. In 3, we just had to remember the area formula, which is pi times radius, squared. Right, we have to square the radius. 12 squared is 144, and that times pi, 452. The main issues on 4, we're not actually reading the how many more square inches. So you find the area of this pizza and the area of this pizza. And this is where, like, circles confuse people. A circle that is twice as wide, right? This circle's twice as wide as this circle. Does not have twice the area. It has a lot more than that. Imagine, I'm trying to help you guys visualize this. Imagine that 9-inch pizza. Pencils.
Let's look at this one.
Yeah, it's the problem on the back. Your 9-inch pizza would fit in here, and another one would fit in here. You have all of this extra space that's like way more than double. So it's a lot more than double. 5, area difference, 69.66. What's left over when we do the subtraction? I allowed any answers, relatively close to that. Volume, that's supposed to be an equals. My pen just got kind of heavy. Length times width times height, 1728. Most of us got that. Surface area tends to be where people start to goof up. And because my pen kind of bled through, I didn't really write on the back of here, so I used the actual answer key when I was grading this section. So 7A, our faces were 120. There were a couple of those. 288 and 312. You gotta realize the back face, the face that we can't see that's hiding back here, is a rectangle that is 26 by 12. Some people thought that that back rectangle was the same as the front rectangle. It's not when we have a prism like this. Then the surface area was 960, and the volume was 1,440 cubic inches, centimeters. Sorry. 8. Hard to do this. 960. Surface area, 960. In 8, we have 28 square centimeters for the shaded rectangle. I think we all got that. 166 square centimeters and 140 for ABC respectively there. Thank you. Here is your test. Very good. We're going over that because we wrapped up the lesson. Any questions on 7 or 8? Surface area, volume. Yeah. For which? For 8, 166. Sorry, I stuck the answers right here. Here's 7 again. So the different faces had those areas. The combined surface area was 960. This is 7 again. And the volume was 1440. In 9, I think we mainly got this one. The tip would be $7.04, like $7.04. Now B was the thing that got people more. B was $58.33. Because if $7 is 12%, I need to calculate what is 100. I could use equivalent ratios there, guys. $7 is 12%. I need to get to 100. Right? We could just figure out what's the multiplier to get there. It'd be like 8 something. And we do the same on top. Yeah. I make mistakes occasionally. Consider that a freebie. Or I might have went and looked at your work, and your work supported something that made me feel like you knew what you were doing, but you made some kind of silly mistake. Which I do sometimes. I'll give you benefit of the doubt. Door. 10. I think most of us got this. At the one speed, we end up traveling 120 miles. At the other speed, we end up traveling 120 miles. So in total, 240. Simple math. Now, 11, most of us missed this. Most of us missed this. And that one I need to see work on your revisions for how you actually get it. Now, even if you got a mastery, I would encourage you to try to resolve 11. I'm probably going to recycle a problem like that. Because most of us missed it. I feel like we need to work on those. So the setup, if we talk about this, Patty traveled from her home on her bicycle and went 3 miles to the beach. So we know the distance is 3 miles. Now, a couple of you made the good question of, like, how do we know she took the same route home or things like that? Like, yeah, but if it doesn't say anything weird like that, just assume they're trying to make it easy for you. Trip took her 12 minutes. In my brain, what that math is 4 minutes per mile. Right? 4 minutes per mile is how fast she was traveling. That's not a speed, right? But every mile took her 4 minutes. I could figure out the speed from that. She returned home at 12 miles per hour. How many minutes less was the trip to the beach than the return trip? There's a funny way to make a linear model of this that I think you guys are going to like. Ah. Here's an hour, right? But that's actually 12 miles. Half of that would be how many minutes? No, minutes. 30, right? Half of that, the 3 miles she's trying to travel, would take 15 minutes. 12 miles an hour, right? Stick with me. 12, that's an hour, right? This is the span of I should put it up here really. 1 hour gets her 12 miles. If I cut that in half, it's 30 minutes and 6 miles. And then cut it in half again, it's 15 minutes, 3 miles. And that's how far she has to travel. So, on your revision, however you think it through, you could use this linear model if you want, or distance equals rate times time. That is our formula we use here. Braylon?
I did that. I just never finished the problem. I just put 15.
Well, if you didn't finish the problem, then you didn't finish the problem. So careful reading. We got to make sure we answer what's questioned. And then I'd say it was about half and half people that got 12. I mean, I had said that it was kind of like an exemplary option, but I wanted you guys to try it. The interesting thing when we look at this, the shaded versus non-shaded region, they're equal. Yeah. That's cool, if you ask me. These weird, like, kind of bird-esque shapes on top and bottom make the same areas as these circles. I think that's kind of cool.
It kind of like a cartoon Spider-Man.
Yeah, right?
It's like that movie 9.
All right, other questions about our Chapter 9 mastery? You have the next 10 minutes to just do revisions if you need it. Mallory? No, so don't worry about revising 12. Here's the technical how they do it. And a lot of you did a really good strategy of saying if, and you know if this was you, a lot of you made situations like if this is 10, or if it's 5. And I gave that suggestion as we were taking the test. If a problem doesn't tell you what something is, it doesn't mean that you can't make it be something. You know rules of circles. If that's 10, then this is 10, and this is 10, or the whole way across is 12. Like, you know these rules, and then you can calculate with that. If instead you said R, and then 2R across, that's how they got this work. Because they made the radius R. Cool. I'm going to shut down the screen if nobody has any other questions. Going once. Going.
The font circumference is saying that it's times pi.
Crust equals pi dough.
Yeah.